Structural analysis of adenylosuccinate lysase using computer-aided drug designing CADD computational tools. This video will demonstrate step by step on how to document and interpret the DNA sequence given. There are two assigned DNA sequences that need to be interpreted. First, BPsp047 and next BPmp090. There are 4 types of databases and web services that will help us to analyze the sequence: BLAST, interpro, rcsb, and catalytic site atlas. We also use 2 types of software known as clustal and MEGA. Firstly, search for BLAST, Basic Local Alignment Search Tool. Once the home page appears, select Protein BLAST. Copy protein sequence from Notepad and paste it on the box provided at the entry query sequence. At the program selection, select SciBLAST. Make sure there is no space between sequence and then press BLAST. In the BLAST program, there will be 3 kinds of results. The first one is conserved domain. The second one is conserved alignment graph. In the conserved alignment graph, if we click at the red line, it will automatically show us the result of the alignment between query and subject, which is the third result. From the BLAST program, we also can get the query ID. Select the ID and paste it on the rcsb website to identify the molecule. Go to Google and search for rcsb website. Paste the query ID to identify the PDB ID. The search will give us few choices of subtype. Select the subtype of interest, and then the DNA sequence of BPsp047 is belong to adenylosuccinate lysase, where its PDB ID is 2VD6. At the rcsb database, we can get the structure of the protein. Select on sequence to get the secondary structure. This is the secondary structure of the adenylosuccinate lysase. At the right side of the home page, select the 3D view to get the tertiary structure of the protein. Next, we can obtain the information regarding the family and domain of the adenylosuccinate lysase subtype through a special software called interpro scan. On the interpro scan homepage, click at interpro to proceed with the analysis. Then go back to the rcsb homepage to get the protein sequence by go to display file and choose FASTA sequence. Select and copy the protein sequence, then paste the protein sequence on the box provided. Make sure there is no space between the sequence and click search. The result will show the protein family membership, which indicate 2 family of adenylosuccinate lysase. Red button indicate family of the protein and green button indicate domain of the protein. Select the IPR accessor number to get the full description of the family and domain. In order to find active site, we need search for catalytic site atlas. Once the home page had appeared, enter the PDB code of the protein at the PDB ID, which is 2VD6. The PDB ID is retrieved from rcsb website. Select Search CSA to find the enzyme active site and catalytic residue in enzyme. This is the result for the active site of adenylosuccinate lysase. We also can infer sequence homology who share the same evolutionary relationship by conducting multiple sequence alignment. Multiple sequence alignment is an alignment that have more than 3 sequences. 2 specialized software are used to find multiple sequence alignment, which are clustal and MEGA. Clustal will help to upload sequence and give 2 types of result in the form of DND and ALN. ALN is the alignment of all those sequences, and we can view it using Microsoft Word, while MEGA is a software that helps us to view the DND. Go to Program and click at Clustal Tool Software. Then at the software, go to File and click at Load Sequences. The sequence will already saved in Notepad prior to the analysis. Then go to Alignment and click at Do Complete Alignment. A pop-up will appear and ask to save the file in the form of DND and AAL. sequences, and this is the result of the multiple sequence alignment. To view ALN, we need to open the file at Microsoft Word and change the font size to 9. To view DND, go to Program and select Mega. Select File and choose Open Files or Session. This is the result of the multiple sequence alignment of BPsp047 with other sequences. The process of analysis for the BPmp090 is the same as BPsp047. Both of the sequence have the same PDB ID, which is 2VD6. 2VD6 is the PDB ID for adenosine lysis. Adenosine lysis (ADSL) is an enzyme that helps to convert adenosine to AMP and fumarate. Defects in adenosine lysis are the cause of adenosine deficiency (ADSL) deficiency. By understanding the 3D structure of the protein, we are able to study the origin of disease and find cure. Structure-based drug design can help to develop a selective drug against the pathogen without causing damage to the host.